looking for. Second of all, we've only done amplitude, period, and phase shift. We haven't done the vertical shift yet. So what we're going to do is we're going to go a little bit further, but we're going to do this on the next graph. So right now, we are at the following points. I'm just going to translate my graph because I feel like I've got too much going on, so it's kind of hard to follow now. And we have our amplitude and our points figured out from our period. So I'm just going to copy those down so I don't get lost and forget what we were doing. So I'm copying all of my quarter points down too. And almost done. Okay, now let's take into account the phase shift. The phase shift had everything moving up 1 unit. So that means the phase shift, where I have points at 2, they would move up to 3. So all my points are going to move up 1 unit. So let's see what that's going to look like. So my -2 should move up to, should all move up to -1. So I'm moving up all my -2s first to -1. Then all my ones that were at 0 should move up to +1. And all my ones that were at 2 should go to 3. And that gives me an idea of what my sine graph would look like now. Again, this is still not what I wanted though. I want my cosecant graph, but I'm almost there. So let's talk about filling in our final cosecant graph. Well, let's see. What is our final cosecant graph? The final cosecant graph was y equals -2 cosecant. Let's see, y equals -2 cosecant of x plus pi/2 plus 1. And let's see how our graph is going to get filled in here. Now to fill in our graph, we do have to realize that our asymptotes are going to be where we originally had our x axis intercepts before we did the shifting up or down before the +1, which would be those purple points. So that is where we're actually going to still have our vertical asymptotes for our cosecant graph. We'll just go ahead and draw those in. There's still the original x intercepts before we did the +1. Then we can do our actual filling in of the graph at secant, which would have to do with taking our points, which are the peaks and the bottoms that we had after we shifted them up 1. And remember that graphs with the secant, or sorry, the cosecant should be shooting outwards instead of pointing inwards. So we're going to point outwards instead of inwards. And there's our final graph for cosecant. Just as a side note, in case they were to ask for something like this, we can talk about the domain. And we can talk about the range. And our domain is going to be everything but where we have our asymptotes. And our asymptotes, if you look at them, are happening at odd multiples of pi/2. So it'd be any x, but x's can't be anything that are going to be an odd multiple of pi/2. And remember how we come up with odd multiples is we do that 2n plus 1. So it can be anything but 2n plus 1 times pi/2, because that will give us our odd multiples of pi for our vertical asymptotes. That's what this thing is. The range, however, is quite a bit different. If you're looking at the range here, the range has to deal with what values our function can take on, which would be on this one. It would be going from negative infinity up to where you have your maximum. So it would be negative infinity up to, we moved it up 1, so it would be up to 1 with a bracket union. Then we'd start at our minimums, which start at 3 and work our way up to infinity. So that would be from 3 to infinity. Again, with a bracket at 3 and a parentheses at infinity. I just wanted to cover that just in case they asked. But again, be careful. When you're filling in your asymptotes for either the cosecant or secant graph, you need to actually fill them in as if they were done before you shift up or down. And the reason why is because that was always done last. You always do what's outside of the parentheses last. So that really doesn't affect your asymptotes. And if you think about it, when you shift a graph up or down, if you shift a vertical asymptote up or down, it doesn't go anywhere. So shifting up and down of a graph shouldn't be affecting your vertical asymptotes ever.